Yeah, hello everyone. Am I audible?
Yes, sir.
Yes, sir, you are audible.
Yes, sir.
Okay. So today is the open session for week 8. So you can ask the query one by one. You can tell me what topic you want to discuss. So you can ask the query. Just raise up your hand and I will take your query. Yeah, so is there any query in week 8 or any topic you wanted to discuss? So no one asking is any query. That means everything is clear in week 8.
Sir, I have one question.
Yeah, Bras.
Sir, in GRPA 4,
Mm-hmm.
it is said that we have to write the solution which will run in big O n time, right?
Yes.
But I write a solution which runs in like n log n time, and still all the test cases are passing.
Okay. So, okay, just I'm looking.
And sir, in GRPA 1,
Mm-hmm. 1 second. Okay. First is GRPA 4.
yes, sir.
Okay, MOM 7. Okay, so that will be one time. So your solution code is n log n.
Yes, sir. But I tried both the solutions actually, n and n log n both, and both are passing cases, test cases.
Okay, okay. So maybe some last time limit is set for this question. So
Yes,
because
sir.
of that,
Let me tell you, I use the inbuilt sort function, so that
actually big O n into log n. So both are not affect too much. N square and n log n, there are much different actually. But n or n log n, so there's not too much effect on actual computed time. So because of that, your code is passed.
Actually, sir, if n is small, then this code will pass. When n is big, it may fail.
Yeah. So we have to take the very much very large value for the n. Then it will affect in the time. So n for example, if you are taking n equal to 1024, so 1024 into 10 equal to, that is the solution for n log n, and 1024 is for the n. So maybe some time limit is set, last time limit is set. So because of that, your code is working.
okay, sir.
Okay, so no problem. But you know the concept, no? What is the MOM median of medians concept?
Yeah.
Yeah. So just always try to write the efficient code.
Yes.
Yeah, sometimes a non-efficient code works, but make practice on only on the efficient code.
Yes, sir. And sir, in GRPA
1
only 4 test cases are passing out of 6 private test
yeah,
cases.
so here actually complexity is log n.
Yeah, sir. Like
Your code is working in the log n complexity, or more than
Yes, sir.
log n.
It is working in log n complexity. I tried running this code on a list of length 10 raised to power 7, and it is taking around 0.03 seconds only.
No. So computer time doesn't matter. Actually, we cannot define the exact computer time because it depends on the machine's configuration. So, what are the complexity of your code?
Sir, it is log n.
Log n. Okay. So, one private test case is not passing.
Two private test cases. There are total 6, and out of two are not passing.
Okay, so maybe some corner case you are missing, I think. If your code is of log n order, so that means your code should be work. I think some corner case is not following in your code.
Yeah, sir, I tried a lot of cases, but okay, sir, I'll try more.
Yeah, others can anyone confirm? Yeah, this problem is facing only by him or others also.
I'm passing 3 for now, not like I will have to look at my code too. But sir, if it would be helpful, like if there was a prompt telling us if there is a time error or a like other type of error, because it's hard to judge.
Yeah, sir, Parth is right. I am passing 4 cases, and I don't know like whether it is because of the time limit or there is something related to corner cases, as you said.
Just wait, I'm checking that how many test cases are following the time limit. So, okay. So problem number 4, no?
No, sir, GRP1.
GRP1, okay. So this one. Time limit is- one, two. Yeah, so I think 3 test cases are very big in private. So maybe some due to time limit, your test case is failing. Test cases are very big, I think approx 75,000 or more than.
Sir, but I use a list of like with like length more than 1 lakhs, and still the time was very less.
So how you are actually you are checking the time on a local system, no?
Yeah, sir. No, sir, not on local system. Checking on Google Colab Notebook.
So just try to make more efficient I think so. That will work.
Okay, sir, I'll try.
So dot index would take order one time, right?
Dot index.
For the list.
Finding the index.
Yeah. The first occurrence of the index.
I think no. I'll just wait. PDS. I'm sharing my screen.
Sir, I'm not using anything like that. Like I'm just calculating the index without using these operations. I think my code should work.
Okay. What approach you are using in your code?
Sir, it is GRPA. So.
No. What approach actually?
Sir, I am
like
using something like binary search, but I have modified that code to reach, like to get the first and last occurrence. And I'm using like two functions, like first to calculate the first occurrence and second to calculate the second occurrence.
Okay. So actually solution code is passing all the test cases actually. So just try to more efficient. I think check your code anywhere you use any end time or something more time operation. Okay. Yeah, concept is fine. I think yes, binary search will be used in this problem. Just check your any operation. Maybe some operation is taking more than log n time.
But sir, you said 3 of the test cases are large enough.
Yeah, 3 of the test cases are large, right? Private test case.
Yeah, but sir, 2 are failing in my case, and I'm not using any operations.
Maybe 2. Maybe yeah, 2 is more large. I think.
Okay, sir, I'll try more.
Sharing my screen. Yeah, so just try to just check again your code and just reduce the some complexity more, or just make more efficient. Maybe sometimes complexity is looking same log n, but some code is taking much time due to some extra sequential operation. Okay, just try to reduce something.
Okay, sir. Sir, I am using that function 2 times to calculate the first index and last index. So is it like because of that the time is like time limit is exceeding?
So what index 2 times? Okay. So can you explain more how you are? For example, this is the sample input. So how you are performing the solution?
So sir, let's say this is a sample input and I want to search 6. So I am using some code like a code, something like binary search to search the first index and first occurrence of 6 and second last occurrence of
Last
6.
occurrence of 6.
So I am choosing that like using that code twice. So
Okay. So you are sequentially performed 2 times.
yeah, with some minor
Yeah.
changes in that.
No, just try to solve in your only one code.
Okay, sir.
So maybe same things I'm saying that maybe you are performing more. Your code is taking more time due to sequential operation.
Yeah, twice I am using
Yeah.
like log n times 2 operations.
Yeah. So complexity is same. We go and log in, but actually we cannot set this complexity in our computer. So we can set only the computer times. So if you are performing more operation in sequentially, so that will affect the time complexity.
But sir, it should pass now because overall the time complexity is log n.
Yeah. Sometimes actually maybe we can write some code is in a sequential manner, but code is very long. So complexity will remain the same, but computer will take last time. Okay, so actually in complexity we ignore this sequential operation. So if we are performing, for example, if we are performing 10 times for loop for n value, okay. So that means we are performing, for example, n is 100 and we are performing 10 times for loop sequentially. So that means we are so 100 into 10, then yeah, 1000 times. So that will take times. So that will increase the time computer times. So, but complexity will remain the end. So
Yeah,
that
sir,
means,
but at least give us some hints like path set, like whether it is time limit exceeded or we are failing some corner cases.
I cannot observe these things without showing your code.
No, sir, in the portal itself, like if we get some error, something like time limit exceeded or something else.
I think time limit. Okay, just write one code which is taking n times or n square times, and just check that what is the error is coming. Just write a brute force approach for this solution.
Okay, sir.
Okay,
Hmm.
which is taking n or maybe n square times. So that means that definitely test case will not pass. And check that is there any message coming or not.
Okay. But sir, it shows only for the public cases, not for private one.
Oh yeah. Okay. Okay, just now this time, sir, just try to reduce the sequential operation in your code.
Okay, sir.
Okay. Snehil, it does give a TLE error, but only for test case. Okay. Public test case. Hello, sir. Why we sometimes return self from function? What does it mean? Nikhil, I'm not getting your question. So, sir, if you have any code related to this query, you can send the code.
Sir, can I ask a doubt?
Yeah.
Sir, why is the time complexity of median of medians order n?
Yeah, order n. Actually, I think sir explained in the lecture.
I'm not.
Median of median.
Yeah.
So how median of median works actually? So this is the code.
So can you give the summary first and then go with the explanation?
Yes, sir.
Summary for all topics.
Yes, so that would be really helpful.
Okay, okay.
We get, sir. I mean, actually, I have some problems, some doubts in the integer multiplication part.
Okay. Okay. So Parth, this is the code for MOM, median of medians. So you can see that here actually we are dividing the complete list into the block of 5 elements each.
Yeah, we are dividing, but dot sort
Yeah.
will still take n
Yeah.
log
So
n.
this no, so not n log n. Actually, the value is fixed 5. The length of x is fixed 5. Okay. So if for example elements are 1000, so this x size will remain the same 5. Okay, so we are taking this 5 size as a constant part.
So it's like 5 log 5.
Yeah, 5 log 5. So that is the fixed value, no? 5
Yeah.
log 5 is always remain the same. So we are taking this part as a constant time.
Okay, okay.
Okay, this is not affecting about the complexity. So after so performing this sort, so we are storing the median of each block of 5 elements, and then finally we are returning the median of all medians.
Yeah. Yeah. Okay. Thanks.
Yeah, this is the region. So nickel delete self.data child. So nickel actually self is representing the reference of object. So we are returning the self. That means we are returning the address of the object, reference of the object. Okay, so for if we are creating a class and we are after we are creating a object for any class, so the self is a variable that contains the address of particular object for class. So we can return this object reference as a self in our function. Okay. Yeah. So basically, these are the content in week 8. So first is so basically what is the divide and conquer? So divide and conquer is a techniques to design algorithms. So in which we break up the problems into disjoint subproblems. So we divide the problem into subproblems and solve each subproblem separately. And then after solving the subproblem, then we combine the solution into the one solution. So like a merge sort. So we divided the list into the sub list. After that, we sort the list and merging the solution. So finally, we will get the sorted list. Same for the quick sort. First, we will start to dividing the list using the partition method. After that, we combining the solution for finally get the solution sorted list. So this is the divide and conquer techniques. First, so according to the name, first we divide the problem into subproblem, that we combine the solution. So, sir, explain first topic, counting inversion. So, what is the counting inversion actually? So, sir, explain some ranking example in the lecture. So, compare your profile with other customers. So, some examples are given. Identify people who share your likes and dislikes. No inversion, ranking identical. So, these are the points. So, what are the inversion actually? So, where your rank is not matching to the other's rank. Okay, so this is I'm talking about the just ranking example. So here, this is the sorting ranks of 1, 2, 3, 4, 5, and another, for example, some other person is providing the ranking 2, 4, 3, 1, 5. So how many inversion are there? So we can, how can we find out this inversion? So that means how many times the order is not coming. Sorry, one, two. So you can see that. So what is the what will be the order? What should be the order? 1, 2, 3, 4, 5, and what is the our ranking is 2, 4, 3, 1, 5. So inversion, that means how many times our ranking is not according to the. So sorry, 1, 2, 3, 4, 5. Inversion actually means inverted. So, okay. So actually we are counting the order mismatch. Okay, so for example, this 2 is coming before the 4, so that is the correct order. Okay, so 2 is always will come always will come before the 4. So after that, if we compare this 4 to 3, so this is not the correct order. So because 3 should come before the 4, so this is one inversion. We are comparing this one part. So this one should be come before 3. There is one inversion, that this one should be come before 4. So there is one inversion. Then this one should be come before 2. So there are total 3 inversion with respect to this one. Okay. Same 5. Yeah, 5 is in the last. So there is no inversion for that. So how many total inversion are there in this example? So there is one inversion with the respect of 3. So 3 should be come before the 4 in the sorted order. So there is one inversion this, and there is 3 inversion with the 1. So total are 4 inversion are available in our this ranking example. So we can graphically represent these crossing points. So we can count these crossing points. So these are representing the inversion. So the order mismatch. We can see that. So the problem is how we can find out the number of inversion in log and log n times. Okay, so the main problem is that. So how can we solve this problem using in the n log n times order? So we can use the concept of merge sort here. Okay, so there, so always we will compare the our ranking order with respect to the sorted order. So for example, this is the solution code for this. So our ranking order is this 2, 4, 3, 1, 5. Okay, this is the ranking order. So how we are okay, I'm just explaining by graphically. We have an initial list. What is the list? So 2, 4, 3, 1, 5. Yes. 2, 4, 3, 1, 5. So how we can calculate this using merge sort? So what we did in merge sort, so initially we divide the problem into subproblem. So we will divide this problem into subproblem. So we are always dividing this problem by the size. Yeah. So this is the. Okay, so n is the length. Yeah. This is. So first we are dividing this into left part. So here the size of the left part is n flow division 2. So we can represent graphically. So for what will be the division here? 2, 4. Okay. What will be the second division? 3, 1, 5. Okay. Once again we will divide. So here this become 2 and this become 4. Same for this. So this become 3 and this become 1, 5. Then once again this become 1 and this become 5. So this is the recursively division of our main problem to sub problems. After that, when we merge these parts, so we will count the inversion order. So how we can count the inversion order? So what our algorithm is saying that so our algorithm is this. So this is the first part. I have all divided the problem into sub problems. So when the size when we are recursively calling this sort and count method, we can say that this inversion method. So if the n equal to 1, if the length of the array equal to 1 or less than 1, then we will directly return the array with the count number of 0 inversion. So that means if there is one element in the list, so we are here, so only there is one element here, okay, single element. So we will return it, the array, to with the inversion number of inversions. So there is no inversion actually here. So, okay, so 2 0 we will return here. Same for here. So 4 we will return 4 and 0. Okay, so there is no inversion for single elements. So after merging this two sorted elements, so single element is always sorted. So we are merging this merging these two sorted lists using a merge method. So we will get this part. Okay. So there is no inversion. We will receive so 0 inversion here, 0 inversion here. So same for the right hand side. This is the one part, and this is the two parts. So this will return the same inversion number. So 0 return, save for 0. Okay, so 1 or 5. So we are actually performing the merge operation in the bottom side. So now we will perform the merge operation on this element and this element. So what we are doing in the merging operation actually. Okay, so just see the algorithm now. So our merge algorithm is this: merge and count. So we are receiving two lists, A and B. We will calculate the size of each list, and we are initialize the some value. So we are initialize some C as a list and ijk as a value initialized with 0. ijk count. Okay. So if k is less than m plus 1, so if I equal to m, we should, so one thing, we always receive a list in merge and count function. So where the size only size of the B can be more than 1 of the size of the A. Always, okay, because we are dividing the, so you can see that. So here, this is the A list, this is the B list. So size of this A list is 1 and the size of the B is 2. So we are passing these two lists in the merge function. So here I'm just okay. So here our list is 3 and second list is 1, 5. This is our A list, this is our B. So we are initialize this. So what is the size of A? M equal to 1. What is the size of B? Equal to 2. Okay. So, and we are initializing I equal to 0, J equal to 0, and C ijk k equal to 0. And we are initialize the count equal to 1. Sorry, 0. After that, we are using I for this list, J for this list, and K for the C list. Okay, after merging. So we will compare the element. Now we will check that in our solution code. If I equal to M. Okay, so first condition is not true. So where I equal to 0. What is the value of M? M equal to 1. Okay, so N equal to 2. So if I equal to M, so first condition is not true. Condition is not true. Okay, so we will move to the second condition. If J equal to N, so no, J equal to 0 and N equal to 2. This condition is will also not satisfy. Then we will check that AI is less than BJ. So what is the AI? AI is 3 and Bj is 1. So this condition is not true. AI is not less than Bj. So we will move to the last condition, else part. Okay. Here that means this condition is not true. That means this else part will run finally. So we will insert the C dot append Bj. Bj element we will insert into the C. Okay. So here we are actually creating one more list. We will append this value here. Okay. So every time when the element B, if this condition is true, every time if this condition is true, B of J is less than equal to A of I. So we will increase the count value because this is defining the inversion point. So we are comparing the element of A and B. So if that means if B element is smaller than A elements, so that means this representing the inversion point. So we will increase the count number. So in this case, so 1 is less than 3. That means we will move to the 1 into the C list, and same time we will increase the count value. Okay, so we will move to the Bj element into the C and increase the J value, increase the K value, and increasing the count by the M minus I value. Why we are doing this? So M minus I. So what is the value of M? 1. And what is the value of is the first loop is 0. So 1 minus 0 is 0. Sorry, 1 minus 0 is 1. So we will assign the count value count equal to plus equal to M minus I. So M minus M equal to 1 and I equal to 0. That means 1. So count become a 1 at this time. That this is representing a inversion. So what is the mismatch order is? So 1 should be come before this 3, but this is not true for this case. So this is the 1 inversion. Okay. So same we will repeat. Now we will compare this 3 value to 5. So now third condition will be satisfied. Okay. So I is remain. So what we have increased now? So we have increased J value. So J equal to 1. We have increased K value. K equal to 1 in the first phase. So now we will check again. So in while loop. So if K is less than M plus, yeah, this condition true. I equal to M, no, this condition is failed. J equal to M, no, this is also failed. Now if AI is less than Bj, yes, this condition is true now. Okay, so we are comparing AI. So I is 0 and J is 1. So this is this 5. So 3 is less than 5. So we will move this 3 into C. So now C become 1, 3. Okay, so we will increase the number of increase the I value 1 and K value. So K 1, now K become 2. Okay, so finally so I become 1. So in the next loop, so the first condition become a true. So next condition, I equal to M, because M equal to 1 and same for the I equal to 1. So this condition will become true. Then we will append the Bj element into the C. So one element is remaining into the C. So we will append this. So we will directly append this remaining 5. So C equal to 1, 3, 5. So all elements are shifted into the C. And what is the count value in last? Count equal to 1. That representing the inversion value. So there is one inversion found in this merging process. So we will move to the back. So now merging this 3 and 1, 5, we will get sorted list 1, 3, 5, and we will receive one inversion here. Okay. So we will receive 1, 3, 5 and one inversion from the count value. Now there are two sorted lists 2 and 4 and 1, 3, 5. we will repeat the same step again. So there are now 2 lists. So I'm representing now this 3, 2, so 2 or 4, and 1, 3, 1, 3, 5. This is the A list. Now this is the B list. Okay, this is I representing 0. This is J representing 0 position, 1, 2. This is representing index, so 0 and 1. Okay, so I J 0. Now K equal to 0. Same things we will repeat again. And what is the M? So M equal to 2 now, and N equal to 3. Okay, so we will repeat the same process. So there is C array, C list. So when we compare the I0 element and J0 element, so this B element here, that means BJ is less than AI. So this is the last condition, else part of our algorithm. So that means we will increase the count. We will increase the count value 1 time. So not 1 times, yeah, M minus I times. So here, what is the which element will become in the C? 1. Okay. So we will increase the count by M minus I. So what is the M? M is 2. What is the I? 0. So 2 minus 0. That means this 1 should be come before 4 and 2. So we are increasing 2 times our count. So okay, so C initially was so count initially was 0, then now it become 2. M
So
minus
3, it was 1 and then it added 2. So 3.
no. So this is the so okay, count.
That was for earlier merge operation.
So no, we are not using actually globally this variable.
Yes, sir. That's why I'm.
Yeah. Actually, we are not.
Okay.
Always we are initialize new counter in merge function with 0. But in last we will add. So we will add in this return function. So what is the
Okay, so my
what is the
mistake. Sorry,
inversion on
got it.
left? Okay. So same, yeah. So count become 2 for this reverse situation. Now see next time. So we will compare 2 and 3. So yeah, A is less than B element. So this 2 will come. Now we next time. So yeah, so I increase here 1, and J is also reached here. So, okay, so this is 2. Yeah. So now we will compare this 4 with 3. So B elements is less than the Ath elements. So what is the size of M? 2. And what is the value of I? 1. So 2 minus 1. We will increase by 1 counter. Okay, so now count become 3. Okay, so now this 3 element will come in C. Now J will come here. Now this we will compare 4 and 5. So 4 will come here. Now remaining elements will come here. Okay, so we will get the sorted list finally 1, 2, 3, 4, 5, and we will receive the inversion value 3 from this function. Okay, so in finally, so we received the sorted list here 1, 2, 3, 4, and 5, and received the inversion value 3. Okay, so this is the inversion value for this function, and 1 we received from the left right part. Okay, so we will add both 3 plus 1, which is 4. So this is the final inversion we are received by the merge sort algorithms. Okay, so we are receiving the count value here from the left part. This is the inversion from the left. This is the inversion from the right, and this is the inversion from the both merging of the L and R part. Okay, finally we will add both 3 parts. So we will receive the all inversion value here from here. So this is the algorithm where we can count the inversion points. So this complexity will be n log n, because we are using the merge sort concept here. Next is closest pair points. Yeah. So I think one graded problem are related to this closest pair points.
Yes, sir.
You know. Okay, so I'm just not showing the solution, but I will take one example how we are performing the closest pair problems. So there is one, yeah, we take one test case. Yeah, three. Yeah, this is the sample test case. Okay. So 215. So this is the 215.
Sir, 311.
311. Okay. 11. These are the point of a two-dimensional plot. So we can draw some like this. Okay. So for example, this is x axis, this is y axis. Okay. So this is, we are just assigning these points. So first value is representing the x, and second value is representing the y coordinate. So first point example, for example, 215. So that means we are representing here 215. Okay. Second point is 45. So 40 is the large value of 45. We are representing so 21. So we are representing 21. Okay, this is 21, 14. 21, example here. 21 and 14. 1 and 4. So 1 and 4. 1 is here and 4. And 3 and 11. So 3 and 11. So I'm just assuming that these are the points on our 2D plot. So what we will do to solve this problem? So first we will sort these points according to the x-axis. So we will receive the sorted list px. So what will be the order of the sorted points according to the x-axis? So this is the 1, 4. Okay, and second is 215, and third is 311. Okay, so next is 4. Sorry, third is 311, not 21. Okay, now 4, 21 and 14, and now next is 45. Okay, so we will sort these all points according to the x-axis. Now we will sort the points according to the y-axis. Py. Okay, so according to the y points, so first what would be the value of the first? We are 21. And sorry, yeah, 1, 4. Yeah, 1, 4. Next is 45.
311.
311. Now
14.
21, 14.
215.
Okay, so 215. Okay, so now this is the first part of the problem. Then we will okay, we will find out the median point. So how we can find out the median point? So we will just take the median part. So from the x this px list. So what is the size of this px is 6. So we will check the third element. So what is the value of x? So what is the value of x is 20. So this is we are just we will take as a median. For example, I'm taking just rx. So this rx value is 20. So we will divide the point according to this median point. So in graph, we can see that we are dividing these all points by this. I think one point is remaining. Oh, same. Okay. So now these 3 points come in the left side. These remaining 3 points come on the right side. Okay, so we are dividing these all 6 points.
Sir, what is the logic behind writing the py?
Py, we are sorting the elements according to the y-axis.
Okay.
Okay, so this value, if you're seeing this value 1, 4, 5, 11, 15, 14, and 15, increasing order. Okay, so this is the first part. We will divide the points according to the median part. So all the first 3 points are come before this median, and remaining are on the right side. So we will maintain this record. So what are we will maintain a separate list now. So we are dividing actually 2 area. Okay, so first is qx equal to, these are the points that comes before the median value. So these are the points. So 1, 4, 2, 15, and 3, 11. And this is the right part, rx. So 21 and 21, 14, and 45. Okay, so we have divided the region according to the median currency. So this is the part qx, this is the part rx. Okay, so in the region we will divide the points according to the y-axis also. So the second thing is q y and ry. Same. So which element will come in the qy region? So we will compare. So this 20, this is the x value. No? So we will compare which elements is come on the left side and which element come on the right side. So these 1, 4, yeah, 1, 4. So same things. Yeah.
1, 4 will be in qy.
Yeah. So qy will be 1, 4, then 3, 11. Yeah, 3, 11.
And 215.
215. Okay. Now the next remaining points are 21 and 40, 45, and 21, 40. Okay, so we divided these points according to the x-axis. Okay, so this is the left part, qx and rx, and we are also dividing these points according to the y-axis. In the y-axis, qy and ry region, so which are come before the median. We are comparing these value according to the median. We have calculated 20. Okay, so this is the order qy and ry.
Hello, sir.
So, yeah.
Sir, what's the logic behind dividing it with reference to y-axis? Means what's the need of doing that? We could have just done it through partitioning x-axis, right?
Actually, we want to apply this algorithm recursively on both parts. So initially, Actually, we are using the divide and conquer approach. We want to do using the divide and conquer approach. So initially, we are applying this algorithm on this px and py. So we are dividing these points into just a half. So these are now qx. So we can call this dividing algorithm. For example, if our dividing algorithm name is what we are taking, just what's the topic? So yeah, closest pair. Okay, so I'm just taking that this is the pair of our algorithm. So initially we are apply this algorithm on py and px and py. Okay, after dividing this, we will apply the algorithm on qx qy and rx ry. So we will call the algorithm again on pair qx comma qy and same pair rx comma ry. So because we want to solve this problem using divide and conquer approach, so we are dividing the points accordingly.
Sir, I guess there is one more reason to like sort it in with respect to the y-axis, because while calculating while calculating the distance between the points around the delta distance, like sir said in the lecture. So we'll be comparing the first element with other 15 elements, right? So
Yeah,
it
that is the last point. So this is the initial point. First, we will calculate the minimum distance on the left part.
No, sir. What I am saying is then also there will be this concept of like the sorting thing with respect to y-axis will help, because we are comparing.
Yeah. Y-axis dividing is useful when we are comparing the distance between the cross line.
Yeah.
Yeah. So for example, now I'm not going in the P. So what we have done this now, so we have divided the point into two halves. Okay. So these are 3 points. Now these are 3 points. So we will calculate the distance between all these 3 points. Okay. So what is the distance between these 2 points? What are the distance between these 2 points? And total we have to calculate the distance of 3 pairs now. Okay, so we can calculate this distance by just using some specific formula discussed in the lecture. So I'm just showing the formula. Yeah. So if we have only 2 or 3 points, we can directly calculate it. Okay. So for example, this. So this is the distance formula between 2 points, and this is the base case if elements are on if the points are only 2 or 3. So we can directly apply this distance formula on these 3 points or 2 points. That will return the minimum distance. Okay, so distance formula is this. In the math, we can use, if we are receiving only 2 points or 3 points, we will directly calculate. We will not call recursively. So this is the base case, and if we are receiving more points in the left part or right part, so we will recursively call on the both part. So in this case, we received only 3 points. For this example, we receive only 3 points on the left side and on the right side. So we will directly calculate these distance between each point. So what are the distance between each pair of points? So there are 3 points. For example, I'm just naming that this is 1, this is 2, and this is 3. So what are the distance between 1 and 2? What are the distance between 1 and 3? And what are the distance between 1 and 2 points? We will calculate these all 3 distance, and we will find out the minimum value. Okay, so we will find out the minimum value from the left side. What is the distance? What is the minimum distance between 2 points? We will find out from here, and same we will apply from the right part. Okay, so we will find out there are remaining 3 points here. So for example, this is 4. This is 4. This is 5 and this is 6. So we will check the distance between all three pair. So what is the distance between 4 to 5 and 5 to 6 and 4 to 6, and we will choose the minimum value. Okay, so we will get two minimum distance between pair of points. We will select the what is the minimum of these two. We will calculate, we receive two minimum value. We will finally calculate the one minimum value. So we received the minimum distance between the all pair of points, but there is one remaining condition. So what we are not actually we are checking only the left part and right part, but we are not checking the crossing points. For example, there is one point here, so we are not checking the distance between these crossing points. So we will now, what is the distance on the left, what is the minimum distance of left and right? This is the finally we will calculate, we will receive this value, and now we will check what points come under this minimum distance region. So we will check the this value min. For example, this is the min value range, 20 minus min and 20 plus min. Okay, this is the region where we have to check the one distance again. So what points come under this region? So we will scan the all points that come under this region. Okay, so when we will receive all the points that come under this region, then we will check the distance between those points. So for example, there is no point for this example, so there is only 2 points. Okay, this is one, this is second, but both are on the right side, but there is no cross points here. For example, if we receive 1 point here, 1 point here, this type things. So we will calculate the distance between these pair. Okay, like this. So we received one min distance from left, that one min distance from the right, then we will calculate the min distance from this part also. Then both three minimum value we will for example, we received this is the min 1, this is min 2. Now we, after these two minimum, we receive min 3, and after this min 3 we received, for example, one more minimum value compared to this one. Okay, so this is, for example, we receive one minimum value, min 4, which is also less than this min 3. That will be the closest point value for the problem. So complexity is reduced because there is no need to check all the crossing points, because as I explained that we have to check only 16 points, 16 next point. We will check always in the sorted order. For example, if we are checking this point, so we have to check the greater 16 point next, which are coming in this region. Okay, so because of this 16 constant value, our algorithm is remain the n log n time. So because of this n log n time is coming from the sorting these points only. N log n time complexity is coming only this when we are sorting these n points. So sorting the n elements takes the n log n times. Otherwise, these all operations we can perform in the big O n order. So total complexity will be remain the big O n log n. So this is the concept. This is the steps actually you can perform to solve. I have a code, but I am not. There's one graded problem in the assignments. Yeah. This is the algorithms are discussed in the lecture. So this is the construct part qx qy. We'll construct the qx value, then rx and ry value will calculate. and we will receive the closest pair, and that means closest pair returning the minimum value. So we will receive the closest minimum distance on the qx qy part, and we will receive the closest point minimum distance value from the rx ry part. After that, we will scan. We are checking so this cross boundary points distance using this point. Okay, scan as I find this find algorithms. Finally, we will return the minimum value for all received 3 minimum value. Okay, so this is the algorithm. Just try to write the code according to these given steps. Okay, so what is the next topic here?
Sir, in the am I audible?
Yes, audible.
Hello.
Yes, you are audible. Oh. Hello.
Sir, in the yes, sir. In the
Yeah,
lecture, Professor means explained that in the specific way that interval like thing in that question closest pair. Yeah. Sir, how this slide, sir?
Yeah.
Yeah, the lower one slide.
Yeah,
Can you
this part.
explain that?
So we are checking the
Yes,
cross
yeah.
edge point actually. So here the point can be actually for. So we will start from the bottom points. Okay. So for example, this is the point. Okay, right here. Okay. So we will start from the bottom because we have already sorted our element according to the y-axis. So we will start from the bottom. Those elements are coming in this region. So for example, these 4 points are coming in this region. Okay. So this is the delta part, and this is the delta part. This delta is representing the minimum distance we have received from the left portion and the right portion. This delta is representing. So when we compare when we will compute the distance between the crossing points, so we will consider the 16 next point maximum. So I calculate this 16 value. So these are divided this region into some blocks. So this total value is the delta, and so divided this as a half part. Okay, so this is delta by 2, and this is next delta by 2. Same for the upside. So every block is representing to the delta by 2 by delta by 2 region. Okay, so when we are for example, we are at this point, so we are talking about these points. So we have to check the next there are 16, I think. So explain the 16 value, we have to check the crossing points actually. So where value can come here? So actually the value can come on the next side. For example, value can come on this point, on this point. So okay, so for example, similar way on the same point in this region. So some mathematical expression I think are used.
So how is this number 16 coming? Means how we are deciding on this that will checking 4x4 boxes for each point?
So 4 for 4. I think this is some. So for example, our point at this point. Okay. So we have to check how many block we. So minimum value can come on this region. I think delta this. So minimum value can become only this delta region. Okay. So actually point can become inside cross points. Output is 16 value or also some kind. This 16 value. Any point within distance delta must lie in a 15 to 4 neighborhood box. Actually, I think, sir, compute this value according to, for example, if there is one point is here, okay, in this region. So we have to compute this 14 up point and this next point below points. We can reduce, I think, this blocks because we are checking the sorted orders. We are always looking on the next point. We will never look on the back points for the each value.
So, sir, we'll look on the upper part of like upper.
Yeah. So we always start from the lower part. So we will first check to this point, for example. So we will always look on the greater value. We will never look the back region. So I think we can reduce this 16 value, I think, because we always check in the cross section.
Sir, actually started in the leftmost part of the block.
Leftmost part. So for example, our element can at this location.
Yeah.
Okay. So what we will, there is no need to check in this region, no? Because we have already checked all the left part points and distance. Here we are checking only the cross edge on the border. So for example, there is another point here. So we will have this distance I have already calculated in the left part. So there is no need to check the same region blocks. So I think, sir, explain according to this situation. So for example, point is here. So 16 value is calculated by these all 4 blocks. For example, these 4 blocks, this and this and this. 16 blocks.
Sir said only the above blocks will be considered, and since like one box is of length delta by 2, and our we already have calculated that the minimum length will be delta. So we'll get like the minimum inside the delta range only. So that delta range is covered by these upper 8 boxes of length delta by 2.
Yeah, so 8 boxes, but sir mentioned that the 16 points you have to check. Why 16 is coming actually? This is confusion about. Cannot have 2
So
points.
maybe it's because
Sir,
any one box contains only one box, right?
Because the element, because the diagonal is d by root 2. If the element of the boxes, then it will be.
Yeah, your voice is breaking. Not audible properly to me.
So actually the diagonal of each box is delta by root 2, right? And therefore one box cannot contain 2 points.
Yeah, so I think sir mentioned these points. I think one box cannot contain 2 points.
That's why it's 16.
That's why 16. No. So if every block contains 1 points.
Still, sir, the maximum diagonal can be delta by root 2 only. So at most, we can go till d, means delta.
Delta, yeah. So
I think that's for the central.
Yeah, that is for the no. So central, for example, if we have our there is a one border point.
On that, like it will be reaching the 6.
So we have to check on, okay. So if there is no point at the median,
Then
okay.
if I rotate it around a circle, like if I have a radius of delta around that, then like it will reach all the 16. Like it may reach all the 6.
No, so where can element can, so for example, there is 1 point, there is 2, so diagonally, I think no, this point. No, but we are taking one condition. So same, I think x-axis or y-axis, we are not taking any points. We are not taking the points on the same x-axis and the same y-axis. This is the one condition. Assumption is also there. So any point within distance delta must lie in the 4x4 neighborhood of the box. Check each point against 15 others.
That's true, actually. Like 16 is like points at most. We are pretty much.
That is what is given at most. Sorry, lie in the 4x4 neighborhood of box. Delta y2, delta y2, so delta y2. Okay, for example, is there any point here? So total delta distance we have to cover in the other region. For example, is there point? So we have to check delta 1.10. So I think some research is okay. Some check again point to the 15 value. Okay, check each point against 15 plus. Scan SY from bottom to top, comparing each P with next 15 point in SY. SY points. Okay, some confusion. Oh. In same block, data. Okay, yeah. So I think this 15 is coming across all the sides, the left side, right side, or bottom also. Otherwise, feeling that we can reduce this 15. Okay, I will check these things. Maybe this 15, I have to confirm this, how it is coming 15 value. Maybe some research paper is available for this. I will have to check this one. Actually, this is a proof things. So maybe some research papers will definitely be available.
So can we think it like this, that suppose there's a point and we have a minimum distance of delta. So from that point taking a radius of delta, because that is the maximum.
Why we are taking radius? So for
Because
example,
that will be
for
the
a-
area, sir. Means in that region, if anything in any point comes within that circle, then only that our distance can be minimum than
no,
delta.
so actually we are always looking on the upper sides.
Yeah, that's also correct.
No?
Yeah,
For example, if we have here points, so we will never look on the back side. We will always look the upper side. So upper side possibilities all so left part is, or we always look on the cross position. We will never look on the same region. If you are pointing in the left side, so we will never look on the left side region. We will look on the right region. So in the delta region, so maximum, if for example, if we have a point on the cross line, so we have to check this region only. This. Okay, if we have a point on the left side. So how 15 actually come is, this is also okay. I will check this also, many papers is available for that or not. Richik is sent something on Google.
Yes, actually, I tried drawing that thing, but like I have marked that circle. So if I like move that center point towards, like if I shift it towards left side, then like still like a delta distance from that point to bit left. So then also I will have to cover all these 16 squares, and if I shift it towards right, then also like I need to cover this 16 points at most, but not more than that.
No, so
So
if for example, if you move to this point on the left side, so why you are searching the distance on the left? Why are you comparing the distance on the left part?
yeah, but I don't need to compare it with the left
Because
section,
that
because
have
it's
already
already
compared
sorted.
in the previous part. We have already
Yes,
calculated.
Yes, that's already sorted, but in the right side, I need to consider it. So I guess that said it as because at most we are searching for 16 points, but we don't need to search for all 16 of them. Actually, I tried implementing it with the 7 points and it worked.
Yes, in 6 so I'm looking. We can reduce this. I think 8 points are.
Yeah, sir.
Yeah, total of 8 points, including the like point where from where I'm trying to calculate it. If I include it, then it's 8 points at most. Yes.
Yeah.
It worked actually.
So, for example, for point on the same median line, so we have to check on the both upper part.
Yes.
Yeah,
so like
that is the reason we can reduce on the 8.
Yeah, that's what I thought.
Yeah.
So again,
So I
why,
think
why 8 points, sir? Can you explain again, please?
actually we are starting comparing from the bottom sides. Okay, we are looking on the top upper points. We are not looking on the lower points. So for example,
Yes.
if we have a point on the this midpoint. Okay. So this is the median part. For example, we have sorted on the right part, and we have calculated for of the left part. But this median borderline is not covered in any region. Okay, so we have to actually we have always take median point is also in the right region.
Yes, actually we consider it, but if we shift that point towards towards the right, then we can consider the left section in a for the purpose of comparison. And if we shift this red center towards a bit left side, then we need to consider all the like right points in the opposite
Yes.
section.
So I think we can reduce more. I think more we can reduce.
Yes, we can reduce it actually. I tried it with the
I
7
think-
points only, like apart from this origin point. So total of 8 squares, and it worked.
Yeah, so 8 is also more. I think we can reduce it to, I think, 4 points.
Yeah, actually tried it with 3
If
and
point,
4 and like.
Yes, so if we are taking point on the right side, so we will check only the left region. There's no need to check the right region now. So it's only 4 points are remaining to calculate it.
Yes, it actually worked with 4 as well, but to be on the safer side, I used 7.
Yeah,
like,
so
total of 8. Yes.
okay. So I think sir explained on some different scenario maybe. So because of that, for the safe side, sir take this 15 points. So we will look some on extra material or some research paper for this, how this 16 value is coming. But currently I'm looking that I think 7 is fine. Our algorithm should work fine for the 7 point also.
So by seven, which part you mean, sir? I mean, which kind of squares you mean? The left one or the right one? Or
No,
the
so
bottom?
I'm actually currently I'm thinking that 4 is enough. But for the safe side, we are considering that.
Sir, how 4 is in?
4 is that because. So, for example, if we have a point, okay, I'm not able to write on this. I'll come back on the slides. Yeah. So 4 is because, for example, our point is on the left side, this region. Okay. So we have to check this 4 region on the right. 1, 2, 3, 4. Because we are interesting only the computing the distance on the cross edge.
Right, sir.
Okay. So this, because of that, I'm just interesting on this 4 region. If our point on the right region, then we will compute. We will check the distance from this left region, 4-point region.
What if the point is on the separator line?
So actually, according to our algorithms, we are median. So we are taking the median. Actually, what I explained. So what we are doing actually. So for at the time of median creation, okay, so we are dividing this 6 divided by 2. So we are considering this median as a left on the left part. Okay, so we are if we are, for example, if we are calculating the median value, for example, if we have received 6 elements and we calculated this median by some, there is another way to calculate the median in the list. For example, if we have list 1, 2, 3, 4, 5. Okay, so what is the median for this is middle element 3. For example, if we have a list for even element 1, 2, 3, 4, 5, 6. So what is the median for this is average of 2 middle elements. This is just a definition of median. So 3 plus 4 divided by 2 is 3.5. So if we are taking the median according to this situation, like so for example, we are adding this after sorting. So our list is sorted according to this. Yeah, so if we are taking median in that way, so 3 plus 20, 3 plus 20 divided by 2, 23 by 2, so that is 11.5. So in that case, our median may be our cross line maybe have some points or not. So in that case, all points will be separated by this.
But sir, we are taking median for x-axis only, but for like particular median point, like here you are taking 3, so we can have different y values, right? So that values will also lie on the separator line.
So for example, if we are calculating the median 11.5, so what the point will come? So 1.4 come on the left side, 215 that will come on the right. No, sorry, x. Yeah, 1, 2, 3 that come on the left, or 20, 21, 14 come on the right. Okay. So it was 2nd, 14. So I think there will anyway. So 20. In that case, 20 is come on the cross line because we have taken this as a median.
Sir, you are right. Like 20,1 is on the cross line, but what if we have another point 20,4 or 20,2, something like that? That will also be on the cross line.
So
Right?
now there is one assumption. No? So I think sir mentioned one assumption. We will never take
Same
2
points, right?
points. Yeah, same points value.
There was an assumption at the start of the.
Yes, yes. So if you are seeing the initially, so there is one assumption. Points. Initially that started. Now check. Step here, point name wallets. Yeah, assumption is given that here. Assumption no 2 points have same x or y coordinates.
Yes, sir, but still 20,1 will be on the separator line, right?
No, so no 2 points. So only always maximum 1 point can come on the separate line.
Yes, sir. 1 point will be on the separator line, but we have to compare that point with other, like on both left and right sides, right?
No, we are not comparing. We will not compare because we are considering this median separator point as a on the right part.
Yeah. Okay. Okay. Yes, sir.
So when we are dividing these points in P, this part, okay, QX and RX region. So we are considering this in 20 point as on the right side. So we will compare this 20 onto the on just left part only. Okay, then I'll check once again what is there is any basic reason to take the 16 value, or just this is the safer. This is only for the safer side. How you did with 7? Did you do code? So according to me, I think I can take 4 value. 1 second, maybe. Yeah. So for example, if here we have a point here. So one second, we are checking that. For example, if we have a point here, so how many possible situations is there? One point, for example, can come this point. Okay. So I think cross point we should also consider delta, but yeah, delta is the minimum distance. Okay, so no point can come in this situation. This is the value of delta. So okay. Okay, actually I think we are choosing this delta as a minimum of on the left side or on the right side, both things. Okay, so maybe the minimum distance can be more than, for example, if we receive the minimum value 4 from here, and if we receive the value for 8 from here, okay, so this delta value will be this 4. Okay, so still we have to check this. Delta region, okay. So points can be increased now. For example, the minimum distance on the right part is 8 or minimum distance is 4. So we are just considering this delta on the both parts. So this is covering the 8 value, sorry, 4 value. Yeah, so we are considering that. Okay. So for example, if there are any points which have greater than the 5 value, that can be possible in this region. So, no, so if so no, so 8 point now, so that is also not can be possible. Yeah. Yes, so yeah, just according to me, I think 4 points we have checked only. So this is the one region, this is second, this is third, this is 4 only. I think so take this 15 value according to the all sides of the median. Okay, I will confirm this and I will check in details also. Then I will reply on this. Yeah, it will work actually. Like we have to take some situation. I don't know what is the situation this for this 16 or more point. Check with 8. Okay, just check with 4. But you have to take, for example, if you have to take the large set of points, then this will reflect. Otherwise, it will not reflect. I think it will also work for the 4 points.
So what does it mean 4, 8, 16 points? What is this?
How many next 4 points I have to check with this cross region. For example, if we are calculating the distance between these cross region points. We have already calculated the distance of all these left part points, and we have already calculated the distance between right part points, but we did not calculate the cross points, distance between cross points.
Yes, sir. Okay.
Okay, so in this part, we are calculating the distance between cross separate aligned points. So, for example, what are the distance between this and this point? Okay, same for this and this. Like this. After calculating this, we can return the final minimum closest point value.
Sir, I checked with 4 on portal. It is working.
Yeah, it will work, right?
So if you are saying 4 means, what does 4 mean? The box.
So 4 means yes. How many points we have to check? So how many possible points can come on the?
Can you draw on this graph which 4 points? If you
so for example, we have 1 point here. Okay, there is 1 point here. There is 1 point here.
That is not possible. What you're drawing it's not possible, because if you're drawing on the right side 2 points like this, that is less than delta, right? And according to the algorithm, 2 points which is lower, the delta will change.
One second.
On the right hand side, if you're drawing like this, no 2 points will be closer than delta, right?
So I think 1 second. So for example, we have a 1 point here. Okay.
Yes.
So delta means our point also can come here in this part also. Okay, so how many points we have to check further? So
So
there
how
is
could you, if you are saying, okay, this delta is nothing but the lowest value, right? On the
this
left
is the
hand
lowest
side,
one on left
the
or
minimum
right
of the
side. Yeah,
lowest.
yeah, yes.
Right? So if you're putting it there, then that will be the delta, na?
Yeah, so this is the part of delta y2, this is the part of delta y2. So for example, delta y2, okay. So our point, 1 second, yeah. So if, for example, if our element can be here, so this cross line. So according to what you are saying that,
So what I'm saying is that if you're having any point which is closer on the left hand side, so that will be one vertical box. I mean, it will have a gap of at least one vertical box. You understand what I'm saying, right? One
vertical
row will
box.
be empty. Minimum distance should be delta between any 2 points on the left hand side. So is the right hand side. But you can have any points which is closer than delta on the left and right. I mean, on both sides of the red line. That's what the algorithm is, right? So we are trying to find out the minimum distance where it is.
We are trying to get the minimum distance across the line, like the
across the line. Yeah, yes.
Delta is the distance which is already the lowest on the left hand side.
Yeah, lower
Or the right
value.
hand side, minimum of left or right.
Yes. So this is the region actually 2 delta. Okay, delta here and delta here. So actually we have to, so maybe some cross diagonal things is also considered, will be considered.
Sir, I have a feeling like I think 4 will not be correct, because let us consider.
Yeah, 4 won't be correct, no?
That's
why I'm confused, like which 4 you are going to calculate.
The thing, like we have a list of coordinates sorting in the sorted in the order of like with respect to the y coordinate. Okay, so we'll take next, like we are comparing first point with next 4 points in that list, in that sorted list.
Okay, the next 4 points in that sorted list.
Yeah.
Yeah, so we have already sorted the points according to the y-axis also.
Yeah. So,
and
like
here we are taking the points only that comes under this region, delta on the left and delta on the right only.
So sir, in that list there may be a case, let us consider we are considering the first element of, like we'll be comparing the first element of that list.
Yeah, this is the first element. Okay, so we will check on the upper side.
Yeah, so sir, this may be possible that the next 4 elements will lie on the left part only, because this point is also on left part, and it may be possible that the next element will also be on the left part, that we have already compared, right?
So no, we will never compare on the left points.
But the thing is, the list contain all the points.
The list contain all the points.
From left side and right side, both sides, the list contain the points. So we have that list only. So we'll take points from that list. So this may be case that we take like 4 left points from left side only.
Okay. But we can ignore, I think, left part points.
So sir, how can we ignore like the left points from the list? Sir, because we haven't specified anything in the algorithm.
No. So we have a median. We have a median value now. So we can check that our point is on the left part of the median or the right part of the median.
Yes, sir, I got you, but we are not doing that in the algorithm. So maybe that is why we are taking 16 points to be on the safer side.
So still, how 16 you are getting?
16 points or 16 square boxes?
So every square box actually can contain only 1 points.
Yeah. No, sir, I am not talking about 16. 8 will be fine, but 4, I think that will not be okay.
If possible, can we do this tomorrow also? Like you can give us some.
I have to check. I think tomorrow Prajis will take the session. I will take on the Saturday. Then maybe Saturday I will discuss about this.
Or you can tell him that you can ask him to discuss this topic. But
Gokul, try implementing that algorithm. You will get to know what
Yeah,
is.
I will try to do that.
So algorithm is working fine, but we have to find out the some test case actually where they can fail for the 4 points if we are taking 4 points. So finding the test case is difficult.
16 will be in that case if you are considering
16
both
16
8
is
and 4, 8.
definitely it will it will definitely will pass all the situation
Yeah.
because we are taking the large value.
So 8 will be good, like according to me. If we consider above 8 squares, then 8 points will be good.
So for example, if we are putting this, so 1 point can be here, and so cross value yeah, so same things. Okay, so currently I'm also not finally conclude these things. Okay, I will check and then I will discuss these things on the next session.
Okay, sir.
Okay. So currently I am just thinking that 4 point is enough, I think, according to me. I will check, but okay. So so next algorithm is the Karatsuba algorithm. So for the integer multiplication. So here we are also there is some specific formula is given by this Karatsuba algorithm. So we can apply this algorithm for the value to multiplication. So what we are doing in this algorithm actually, so here we are receiving two value. For example, we are receiving this 2, 3, 4, 5, 6. This is the first value and this is the second value, and this is the size of our elements. So the size of our elements is 4. So according to this, if size of our elements is 1, so then directly we will return the x into y. So if your size is 1, so then we will return the x into y. Else we will divide this value as a half part. So this m equal to n by 2. So what is the size of m is 4 initially. Sorry, 4. What is the size of n is 4. So 4 divided by 2. So this, we will receive this m value as a 2. Here what we are doing actually, so we are just breaking this value as a 2 part. So we will just breaking this 3, 4, 5, 6 value as a, okay, just I'm taking the example. For example, we have received initially 3, 4, 5, 6. So 3, 4, 5, 6. So second value is 8, 9, 0, 2. Okay. After that, we will calculate the xh, which will be x remainder 10 to the power m. So m is calculated by this upper line. This is 2. So we will receive the value 34 here by the this syntax. Next is xl. Okay, so xl equal to, we will return this part 5, 6. Same for the yh, we'll receive 8, 9, and yl we will return 0, 2. After that, we will calculate the a value xh plus xl. So we will receive 34, 34 plus 56. Then this is 90. Then what is the value of b? Yh, so 89 plus 2, 91. And then we will recursively call this fast multiply algorithm on the xh part and yh part. So xh part and yh part, this part. Okay, so for this two line, and third line is our fast multiply on a and b. We are also performing this. We are recursively call on this part also. So after recursively call, so initially we have two value, then we are recursively call once again fast multiply fm on 34 and 89 with size 2. Okay, and second call is FM 56 and 02, the size of 2, and next value is FM this 90, 191, 2. Okay, so we are recursively call these 3 points and receiving the returning value PQR. Okay, so once again we divide this value inside this recursively call, then we will divide this as it XH equal to 3, XL equal to 4, okay, YH equal to 8, YL equal to 9. Same we will calculate the once again A value and B value. Same we will repeat for this, same we will repeat for this recursively. Okay, then once again we will call recursively call, then our base case condition will be satisfied. This is the base case condition satisfied n equal to 1. Then we will directly return the value. So finally we will receive 3 value PQR, and then we will perform the operation from here. We will apply this formula on this PQR value. We will get the multiplication of the input value. So this is the specific for formula based algorithms. So complexity, I think sir have already proved that every time we are divided, we are recursively called 3 times, and we are dividing the size of n by 2. So this is the 3t n by 2. Okay, so and every time we are taking the n steps. So this is approximately n steps to compute. What is this n steps? 4, 1. Okay. So 3t n by 2 we are dividing, and how this n values come actually under the constant operation.
Sir, I have a question. In the lectures at the times, in lecture 8.3 time step 6.06, there Madhavan sir told about x1 being x1 into 2 to the power n by 2. So it shall be 10 to the power n by 2, no?
No, sir, actually explain the binary numbers multiplication. If you are taking 2 to the power in the formulas, that means your multiplication on the binary numbers. Okay, if you are taking this value is a 2, this is representing as a base. What is the value of what is the base value of our numbers?
So taking 2 means the number has size 2
Yeah,
only.
the input. No. If you are taking this 10 as a 2, that means your input is as a binary number. 0 1 1 0 0 is in this form.
Okay. So for then for octal we have to take 8 and hexadecimal
yes.
16.
Yes,
Okay.
yes.
Okay.
Okay, so I think sir explained the complexity using some binary tree methods. I think it's slides. Count and watch. This is better. 3. Integral multiplication. So in last this is the part of the complexity. algorithms. If T1 equal to 1, then this one steps. If n, that means 3t. So we are dividing, we are recursively call our algorithm 3 times. So we are taking this 3t n by 2. And each step is taking n times. 2 to the power n. Okay, so yeah, so if we are calculating this power things, so I think that is coming from this n side, because we are considering this power n value here. So after some calculation, mathematical calculation, equation creation, so finally we will get the complexity, these things. Log 3 is approx equal to 1.59. So this is the final complexity, n to the power 1.59. So normal multiplication takes n square times, but using this methods, Karatuba method, we can reduce this n to the power 1.59. This is the standard algorithm. Yeah, next is quick select. Yeah, so quick select is basically we use to find out the kth largest or kth smallest element, and we are actually using here the quick sort concept. Here we are using the quick sort concept. So we know that every time the partition method return the actual position of our pivot element. So we can use this concept in this quick select algorithms. So if, for example, if we are finding out the kth smallest element in the list, what is the kth smallest element in the list, so we will just take the pivot and check that what the pivot position is returning by this partition method. If the position written by this partition method is represented the actual position after sorting the elements, so we can say that this is the fifth. For example, if we are taking this, for example, if we are taking one unsorted list, so 4 or 5 1 6 3 2 8 7, like this. Okay, so if our k value is for example third smallest element, so what is the first smallest element is 1, second smallest is 2, and third smallest is 3. Okay, so our output should be written as a 3 answer. So how what we are concept is using, so we are concept actually using, we just taking as a pivot element, we are taking the first element as a pivot in the similar way of quick sort algorithms, and check that what are the what will be the return position of this 4. So after completing this process, so we will compare the elements one by one from this 4, and we will shift it this 4 according to the our partition methods. So after partition method, completion of the partition method, so we will get the element like in that way. So for example, this 4 is here, so how our algorithm is okay, so executing the code. Okay, so we will check that what is the our lower value and what is shifting. Okay, just printing the value here, print L and lower than. Okay, and we will take the same list. So 4516, 4516, 3287, 3287. Yeah, 3287. Total elements are 8, and we are interested to find out the third element. So we are printing here quick select algorithm. So what will be the first? Yeah, so this is the first partition where we are getting the position of 4th. So, and we are receiving the index also. This is the 3. Okay, so 213 at the left side we have received. So 213, and this is the 4. And what will be the is the order of the right side? 5 6 8 7. So 5 6 8 7. Okay, so after first partition process, so we received that the actual position of this pivot element. This is the index 3. Okay, so this is the 0 1 2 3 4 5 6 7. So we can say that this is the 4th smallest element, and we are finding the 3rd smallest element. Okay, this is the actual position after the sorting element. So this 4 will come at the 3rd position after the sorting of all elements. We can say that this is the this is at the 4th smallest element in our list. So we are interested into the 3rd smallest element. So we will apply the quick sort algorithm on the left part, because we are received at the 4th smallest element, but we are we are searching for the 3rd smallest element. So we will ignore the right part completely and apply the quick sort on the left part only. So now we will apply the quick sort on the left part. Then we will consider that this is a pivot element. After completing this process, so we will receive the next sorted these things, this one. Okay, so 1 2 3 4 5 6 8 7. So 1 2 3. So we applied out the quick sort only this left part. Okay, we are not touching this right part now. So what will be the index we have received? We have received the 1 index here now. Okay, but we know that this is the 2nd smallest element, not the 3rd smallest element. Now we will apply the quick sort on the right part only. So we will apply the quick sort on this part. So if we are applying the right side, there is one, I think, a base condition. If a element is single, so we'll directly return. So your position will remain the same for the single element. So finally we will return the position, this one, 3. So this is the 3rd smallest element in our list. So every time we are reducing the part, reducing the approx half part according to the pivot element, and we are searching our kth smallest element or largest smallest element in the log n time. But in the we know that the quick sort takes n square time in the worst case situation. For example, if our list is in the sorted order or reverse order, so the complexity will remain the n for this operation. So we can improve this quick sort algorithm using median of media MOM algorithms. So this is the simple version of the quick sort, and using this median of mediums algorithm, where we are actually dividing all the elements into the groups of 5 elements, and after grouping of the 5 elements, so for example, if we are receiving this is our elements, So this is 15 elements. So how we are calculating the MOM median of medians? So median is not guaranteed that it will return the exact median element, but it will be the closest of the median element. So these are our elements. We will break these elements into the block of 5 elements. So after, and we will sort these 5 elements also. So initially 5 elements we have 1, so 2. Okay. So we have first 2, 3, 4, 5, 6. Okay. This is the first 5 block after sorted, and next sorted block is 1, 7, 8, 9, 10. And third 5 block after sorting is 11, 13, 15, and 17, and 18. Okay, so these are the 3 blocks we will calculate it. After sorting, we will select the median element of this. So what is the median of the first block is 4, and second median block of median is 8, and third block median is 5. After receiving this, we will apply the MOM algorithm on this. So elements are less than 5. So we'll sort these elements once again. So 4, sorry, I think what is the MOM working? Yeah. Yeah, so if the length is less than equal to 5, L then sort and return the length by 2. Okay.
Median.
Okay. So we will return the value. So after sorting 4, 8, 15. So this is 15. Okay, okay, sorry. Yeah, because of that I'm confused. Yeah, so median of these 3 elements is this 8. So our algorithm will return the median value as 8. So this is the process to compute the median. So it will take we go order of n times, because we are ignoring the constant time to sort the 5 elements. Okay. Yeah. So we are ignoring this sort because we are taking always the constant value 5. So this median of median takes the complexity order of n. So we can use this function to choose our pivot element in our quick select algorithm. So this is our now the name is changed, fast select, and we are using the pivot element using this MOM function. So it will take n times, order of n times, but so there is a chance to come this pivot element at the mid position now. So we are assuming that we always divided our main list into 2 equal halves, approx equal half. So according to that, our complexity will improve, and the complexity to find the smallest and largest element to log n times. We can improve using this MOM algorithms. So only the changes we are selecting this pivot element using this MOM algorithm now. So this it become a fast select algorithm. So the worst case situation of the previous algorithm is improving by this algorithm. So last topic is the recursion tree. This tree is actually the way to compute the complexity of our algorithm. So
Sir, how the complexity of that fast select becomes linear? It should be n log n now.
No. Log n. One sec. One second. Yeah. Oh, sorry. N log n. Yeah. Actually, we are performing the sorting also. Actually, okay.
But sir, in the lecture, sir mentioned that fast select runs in n linear times, but it should be n log n.
No. So quick sort becomes quick sort.
No, sir, I am asking about the fast select algorithm, like how it become
Yeah, it become linear. Oh, okay. Okay, so I'm just seeing this. What sir mentioned the complexity.
So, sir, everything is same. The change is of only we are choosing the median pivot element using the MOM.
So selection becomes big O n. Quicksort becomes n log n. Medium blocks.
Both should be n log n because everything is same except the pivot using part.
Yeah, so we are improving the just choosing the pivot element. After this choosing the pivot element, so our complexity will big O n log n in worst case. Because in quick sort algorithm, it takes the big O n square in worst case. So we can improve this worst case situation using this good way of pivot selection.
Yeah, but sir, what I'm asking is like the complexity of fast select will be n log n, right?
Yeah, fast select is n log n.
Okay, sir. Thank you.
One second. Okay, 1 second. Actually, I have to look the code again. Actually, we are calling the quicksort only one part. One. So fast select. If the element will at the fast select, we will call it the lower part or upper part. So every time we are reducing the element by half of the numbers. Okay. Initially, partition takes n times, and then we will reduce this n by 2.
So what will be the recurrence relation here?
So recurrence relation will be every time we will reduce the length of our list by half of the numbers.
So Tn by 2.
Yeah, Tn by 2 plus n. So Tn by 2 plus n. Yeah, initially we have an element. After processing this, so we are applying this Tn algorithm. Then we will apply again T on n by 2 part, and it takes n time to process. This will be the recurrence. So first is n. So what will be the series n plus second is n by 2 plus n by 4 like this. So complexity is plus. So what will be the sum of this type of series? Here, so this is the log n step actually. Okay. Log n steps. So we cannot say that the time. Okay. So okay. Yeah, so it will take the linear time actually, because we are receiving this equation n plus n by 2 plus n by 4. It will reduce to 1 in the log n steps.
So this is from Tn by 2, right?
Yeah, Tn by 2.
Okay.
But
this step will take log n and the processing time, and so n plus log n overall n.
Yeah, so overall, actually, we are taking the larger value of the all parts. Because of that, this is the linear time BON.
Yeah, since in the quicksort we are we like recursively call both the half lists.
Yeah. So we are in that quicksort. So the what is the recurrence relation of the quicksort is we are calling the 2 times actually.
So Tn by 2.
Yeah, so initially Tn, then we Tn by 2 and Tn by 2. Okay, so every time the steps is partition step is always n. This is also n by 2 from here, n by 2 from here. Okay, so finally this tree we will reach at one on the log n level. So this is the first level, this is the second. So log n level we reached at the single with the single element. So because of that we have received n element each. We are performing n steps on each level. So because of that complexity is n log n. In worst case, there is a situation. So t we are starting from Tn. Always we performing one step, then we performing Tn minus 1. Will be T1 and Tn minus 1. Like this. So these total level are increased to n, and each step takes n. So level is also n, and each level takes the n times. So because of that, n into n is the n square complexity. But here what we are doing actually, we are always dividing. Yeah, so we are starting from Tn, total n steps. In next time we are just dividing by n by 2. So step is also decreased n by 2. Okay, so in log n steps, so because of that we are considering this large value. Consider this n value of complexity. So complexity is order of n. Okay. Okay, so this is the last, and recursion tree is just the way to calculate the complexity using the tree, using the just representation of the tree diagram. And we can, there is some formula is also given by sir in slides. So we can use this formula to calculate the complexity for our algorithm. If we are dividing the problem in a different way. So for example, if in merge sort, quick sort, we always divide the algorithm into 2 parts. So we can draw the tree for that, and we can also find out the complexity in the same manner we have created these things. So sometimes we can calculate the complexity using this tree, because tree way, recursion tree way. So this is the big 8. Okay, so any other query? So I will search the closest points part, what's the reason behind the 16 value. Any other query?
No, sir, no other query.
Okay, thanks. Okay, so I'm closing the session.
Thank you, sir.
Sir, thank you, sir. Thank you so much.
Okay,
Thank you so much, sir.
okay, welcome.
Thank you, sir.
Okay. Yeah, bye.
Sir, bye. Good night.
Good night.
Good night.